measure of the extent of the reaction and is dependent on the temperature of the reaction. The Van 't Hoff equation describes the relationship between temperature and the equilibrium constant. Lane K2/K1 equals delta H/R1/T2 to 1/T1, where K1 and K2 are the equilibrium constants at temperatures T1 and T2, respectively. Delta H is the enthalpy change of the reaction, R is the gas constant, and T1 and T2 are the temperatures. The Van 't Hoff equation shows that an increase in temperature leads to an increase in the equilibrium constant for an exothermic reaction and a decrease in the equilibrium constant for an endothermic reaction. Factors affecting temperature dependence. The temperature dependence of chemical reactions can be influenced by several factors, including the activation energy, the reaction mechanism, and the presence of catalysts. Reactions with higher activation energies are more sensitive to changes in temperature than reactions with lower activation energies. The reaction mechanism can also affect the temperature dependence of a reaction. Reactions with complex mechanisms are typically more sensitive to changes in temperature than reactions with simple mechanisms. Catalysts can also affect the temperature dependence of a reaction by lowering the activation energy, which makes the reaction more sensitive to changes in temperature. Applications of temperature dependence. The temperature dependence of chemical reactions has many important applications. For example, the Haber process, which is used to produce ammonia from nitrogen and hydrogen, relies on the principles of temperature dependence to maximize the yield of ammonia. Similarly, the production of ethanol from glucose relies on the principles of temperature dependence to control the extent of the reaction. Temperature dependence is also important in many biological processes, such as the regulation of metabolic pathways. Effects of temperature on reaction kinetics. Temperature plays a crucial role in determining the reaction kinetics of a chemical reaction. A change in temperature can affect the rate of the reaction, activation energy, and reaction mechanism. Generally, increasing the temperature of a reaction results in an increase in the reaction rate. This is due to the increase in kinetic energy of the molecules, which enhances the rate of collisions between the reactants. According to the Arrhenius equation, the reaction rate constant increases exponentially with an increase in temperature. Activation energy. Activation energy is the energy required for a reaction to occur, and it is influenced by temperature. An increase in temperature results in a decrease in the activation energy barrier, which means that more molecules will have sufficient energy to overcome the barrier and react. This leads to an increase in the reaction rate. Reaction mechanism. The reaction mechanism describes the steps by which reactants are transformed into products.